Okay, in this presentation we are going to look at some complex numbers. So this is from a tutorial sheet I've written up, or I am writing up. So we have z equals this fraction over here, the square root of 5 plus 1 divided by the square root of 5 minus 1. Okay, so essentially what we want to do is express the solution, simplify it, okay, get it in terms of a plus ib, and then express it in polar form and exponential form. So it's a straightforward enough operation. Okay, so what we're going to do here is just off to simplify it. What we're going to do here is just start us off. We're going to let that equal to z equal to that. Essentially, what we're going to do is start with the denominator. Okay, and what we're going to do is to sort of simplify that expression. What we will do is multiply above and below by the complex conjugate of the denominator. The complex conjugate is essentially if you just the same. If you have a plus ib, the complex conjugate is a minus ib, or vice versa. So we have a minus here, so we have a plus here. Okay, and yeah, that's it really. That's what the complex conjugate is about. So, uh, so we have two sort of calculations to carry out. This actually, if you're sort of familiar with this, this is the difference of squares. So this actually is root 5 squared minus I squared. Okay, so that's the difference of squares. The numerator is actually just a little bit tougher. Okay, so you just have to work through it. Okay, so let's just sort of work that out. So that, yeah, the difference of squares. So we have the denominator will work out as 5 minus I squared, and minus I squared is actually just simply 1. So we have 5 plus 1, which is 6. So that actually works out to be nice and straightforward. So we got a integer there, just a real number only value, which helps a lot. Okay, and when we multiply out the top, square root of 5 times the square root of 5 gives us 5. Plus 1 times, sorry, plus what, plus I times plus I will give us plus I squared, which is minus 1. Okay, and then we have square root of 5 times I plus the square root of I, or square root of 5 times I. So we have uh, I times 2, I times 2 times the square root of 5, essentially. Okay, so just sort of simplifying that expression, we would get 4 over 6 plus I times 2 I times 2 square root of 5 over 6, or we could simplify it a little bit more. We could call it 2/3 plus I times square root of 5 over 3. Okay, so that's sort of as much as we can. That's that expression simplified. Okay, so what we have to do now is put into polar form and exponential form. Okay, so essentially what we're going to do here is we're going to calculate the modulus. Okay, or the modulus. Just a sort of, the modulus is denoted R, and the argument which I will denote theta. I'll just get to the modulus first. So we have a plus ib. Okay, this is in the form a plus ib, and the modulus is simply the square root of a squared plus b squared. Okay, so square that, add them together, get the square root of the whole thing. So we get the square of 2/3 is 4 over 9. The square of the square of the square root of 5 over 3 is 5 over 9. So we have 4 over 9 plus 5 over 9, which is the square is 9 over 9. Get the square root of that, and we get the square root of 1, which is equal to 1. Okay, so that is the modulus. Great. So now we just need to calculate theta. Okay, so there we go. Okay, sorry, I just paused there just to sort of make a note of something actually. So I just added in something here. So essentially what we have to do is find theta. So we have tan of theta equals 5 over 3 divided by 2 over 3. Just actually important to note, this is in the first quadrant of the argand diagram. So this is a very simplistic example. So essentially it's a straightforward enough division in this case. Okay, so but it just actually, both cases are positive. So essentially what I'm going to do there is just actually make a quickly do this one very quickly, but just to remark that this actually will be both the numbers here are positive. That means this is in the first quadrant. So this is a very simple example. Just watch out for this. Other examples may be a little bit more complicated. Anyway, I'll leave that. So it's actually just to sort of make a remark upon that and move on. So essentially, this actually works out to be very simple. Just divide one by the other. So we get square root of 5 over 2. Get the inverse of that. The inverse of that tangent value, and that turns out to be 0.841. And again, be very careful about this. Again, this is particularly relevant when you're calculating the quadrants are very important when you calculate this. Okay, so I'm just being very careful about that, just to mention that. Okay, and again, it is a sort of crucial thing. It's the type of thing you can mess up later on with when the examples get a bit harder. Okay, so the quadrants are very important. I'm sort of overstating it here. Anyway, in polar form, z is equal to r, which is the modulus cos theta, which is the argument, plus I sine theta. Okay, r we found out to be equal to 1, capital R there. So that's why it just disappears here, just 1 times that. Theta we find to be 0.841 plus I sine 0.841. That is the answer as far as polar form is concerned. The exponential form is something very similar. R times e to the I theta. R again is 1. Theta is 0.841. So simply we have e times I to the 0.84. E times I to the power e to the power of I times 0.841. Tongue twister there. Okay, that's it.